And so welcome everyone to the first demo day of the Retrieval Market Builders working group. And today we have a packed agenda with 6 demos of all the work that people have been putting out since the Retrieval Market Builders Summit. And so the typical way that we go about these demo days is we pack all the demos to go first. And while people are presenting, we invite everyone to ask questions, and you can always do that through Zoom chats. But an even better way is actually to post the questions in our shared Slack channel, because then we can follow on each of those questions, those questions asynchronously in threads. Just makes the overall communication way more fluid. At the end, if we still have minutes to visit those questions, then we'll start from the top to bottom for the ones that we have time. But given that everyone packed a demo today, so I'm not sure if we will have a lot of time for discussion live. Make sense to everyone? All right, some nods. Well, welcome to everyone that just joined. Okay, so let's get started. Alfonso, want to kick us off with the first demo?
Yes, so hello everyone. I guess you see a few slides. I'll try to be fast. I want to introduce what we're doing around smart records. Smart records, in the end, what we are trying to do is a public blackboard for protocols. So this is part of our composable routing project. In the composable routing project, in the end, what we're trying is to make routing in systems and in distributed networks something that can be composable, so that protocols don't depend one to another. We can use the one that we want. We can configure the behavior of our content routing, and that's the idea, the basic idea of composable routing. As part of composable routing, we have smart records. Smart records is the persistence layer. So in the end, is the data that protocols will use to interact one with each other. So what we're trying to solve here is that actually right now we don't have a standardized shared public medium in order to share data between different protocols. We have the DHT where we have provider records, peer records, and we can check information, but it's only used by the DHT. We don't have a way of maybe fetching these provider records using Bitswap or any other protocol. And the idea is to generalize the DHT and the key value put get of the DHT so that we can store arbitrary data and we decouple it from the transport. So we can use it by any protocol in order to fetch information and populate information in this persistence layer. And actually, what we're trying to do is, in the end, to have a public platform where we post JSON documents. In the end, it's not JSON documents; it's IPLD, but you get a sense. And the kind of use cases that we envision with these smart records and potentially with composable routing is that we would be able to deploy new application without upgrading the whole network. So we would be able to use different provider records or store whatever we want in the DHT without having to mess around with the DHT protocol implementation. We would be able to have different protocols and different versions coexist. We could have different versions even of our retrieval market protocol, leveraging the information that these different versions are using in the system. We could do fair exchange, and we could unlock other kind of information where we store like indexing information. We can have orders being stored in smart records, and we'll see in a moment a quick example. So the model is pretty straightforward. Each peer has their own space in the smart record virtual machine in order to store information, and they're able to store whatever they want. And they only merge and like mess around with the information in their public space. And then someone that is fetching the record would be able to aggregate according to the information that peers have been posting. This is the data types that we have. In the end, it's IPLD with an additional type, which is a predicate that is used for smart tags, and also to trigger different information. So trigger different actions in the smart record, in the composable routing and in the smart record framework. And for, all of these data also has a metadata, so we will be able to add metadata, like for instance, a TTL, in order to let records expire. And what I want to show you now, there are a bunch of repos with code that you can check out, and these can be used. I can share it in Slack, and I want to show a quick example of a chat application built on top of smart records, and also how reachable smart tag and some smart tags would work in an example. So I'm going to share. I don't know if I'm running out of time. Please ping me if I'm over time. Okay, cool. So here, in the end, what we have in this chat application is we will start a server. This is a smart record server, so it will be hearing for put operations or get operations from other clients. And we start two different. So here, what we're doing is starting two different. We can put a nickname. We're starting two different smart record clients that what they will do is send their messages to the smart record server and put information about the messages. These messages have a TTL, so it's like messages with the expiration in the chat. And like this is straightforward. Like here, what we're doing is just syncing the state of the smart record in the smart record server, and we would be able like to see the different messages, and that's it. And what is cool about this is that we also have a tool that we call Debug. We call Debug. It's an easy tool that we use to debug smart records, where you fetch the smart record in a certain key, and you can see here that with each, this is what we're storing in the smart record. So for a nickname, we have the messages and the different sequence numbers that would allow, like the client in the end, what it's doing is fetching the records and make sense of what are the updates and what is the information that it needs to show in this UI. So this is an example of something that we could do. And I'm going to show you what are smart tags. So here, what I have is a simple example where what we're doing is initializing 3 different hosts. We connect 2 of them. We put H1 being the server, the smart record server, and H2 the client, and we have a bunch of records that we'll see in a moment that have predicates. And these predicates, what they will do is trigger actions. And what we do is like update. We have 2 different records, and we update in one of the servers these 2 records. And what is cool about this is that if we run the example, we start the host. This is so we'll walk you through the records. That is the thing that we're interested in. So these are the 2 records that I'm going to input in the server. We see here that we have, this is the predicate. Here, this predicate, what it says is that we check that what it's behind, after it, it's a link. Then here we would have a link for a CID, and we can have like a list of different places where this CID is. So we could store information about what is the link in IPFS, and then the peer ID. We could put the sector ID in case it is also in Filecoin, and we could put a smart tag sealed in order for the virtual machine, when we update in the record, to check if this is sealed or not, so that the people that get the record know what is happening. And here we have like 2 smart tags that are actually implemented, which is the dialable one and the connected one, that are used for when we update the smart record, the virtual machine, the smart record will check if the server is connected or dialable, or can dial these multi-address. And here we have another smart tag that checks the multi-address and checks if this is multi-address. This will be processed. So when we update, here we have another record. These are merged because I'm the same peer writing the same record. And we see that here the predicates are removed because the VM makes sense of it. Like here we see that it checked that it was a valid CID, so it left it there. Here, if it was sealed and unsealed as it was determined, it will be it wouldn't be removed. And for the dialable, according if it's dialable or undialable, it will change the predicate to not dialable so that others can see, and in the case, I think undialed in the case that we could dial. So this is an example of what smart tags could do, that in the end is giving a bit more of intelligence to the smart record, so that when we fetch it, we have additional information that we didn't have. And yeah, hopefully I didn't run out of time. Thanks.
Thank you so much, Alfonso. Super cool demo. Again, if you want to ask questions to Alfonso, please post them on the Slack channel. If we have time at the end, we'll do them live. Otherwise, we'll just follow async. Let's go to the next demo. This one from the Myel team. Thomas, are you ready?
Yeah. So I'm gonna demo our gateway. To do that, I'm gonna use actually an app that was built during the Web3 weekend. 1 second. So this is kind of an app that's built on top of the gateway that we made. So it's kind of a way to start from the use case mostly to really narrow down on what is needed for the retrieval market to function and kind of power some of the current Web3 use cases that are out there. So we kind of made this concept during Web3. And so it's kind of this basic kind of dApp experience that you have. And for example, I'm kind of minting an NFT. So I'm going to upload something. I want to upload this GIF of Fastly being down today to make this kind of an important moment in history. So this is the GIF. It's ready to submit. And so I'm just kind of selecting a cover. And then once I'm ready, we kind of imagine how it would look like for it to pay for the storage in that situation. But right now, this is not implemented. And so right now, what happens is it's immediately getting cached on our gateway. So then when it's done, you kind of have that root CID and everything, and then it's already kind of cached there on the gateway. And so then what, you can just have it there, and eventually we're looking at ways. I mean, it's not a priority, but eventually it could be aggregated into a storage deal. But what we're most interested in right now is kind of the retrieval capability. So right now, caching is satisfying for this app. And so our users can kind of run a pop node if they want to replicate the content. So by default, when it's published to the Myel node, it's replicated. You can pass it as a HTTP header. So I'm just going to start actually with the temporary repo, because I want to make sure the node is completely clean, and so I can pick kind of my region. So right now I'll just pick global and Europe. I mean, actually, so global is kind of the free region, so I don't need to pay for transfers. And so automatically I'm kind of joining the network, and I can kind of see if I'm connected to the nodes. So it looks like I'm connected to the gateway and another node. And so by default, I think it takes a little time. So it would take 60 seconds. But within this first seconds, I'm basically automatically replicating the most popular content that's on the gateway. So by joining the network, I can already have content dispatched from me to my node. So I think we're just going to check it out, see if there's anything. So it looks like it's still taking some time to get here. But what happens is I'm also exposing the same gateway. So like the gateway that's running, that's hosted is the exact same way, same node, same code that's running here. So if I wanted, I could run this dApp with my local node and not rely on our gateway, for example. And so if I want, I can retrieve that content. So I could retrieve the content from the vault directly from and then it should load it if everything goes well. From the node. So this is actually telling me that it's replicated 15. Okay, so this is giving me some information about what is in that transaction. So this is the GIF. There's actually the username as well, and the preview. So I'm actually interested in the GIF. So I'm just gonna go like this, and here it is. So it's fetched it from the gateway. So I'm actually now I'm fetching. I'm obviously caching it, but I should be. Looks like there's a little error here. My node crashed. But essentially, what happens is I should have as well some of the most popular content from the gateway cached as well here. And so kind of the plan that we're doing is basically the gateway doesn't cache everything, so it doesn't have unlimited storage. So what happens is it only, it has kind of this eviction scheme where it will just start offloading and removing the least popular content, but it automatically replicates content to other peers in the network. So by default, once it wants to get content that it doesn't have, it will start paying providers to retrieve that content from other nodes that join the network. So this is kind of how we're onboarding our first providers. And then the gateway is a way to start onboarding content and caching it. And then we're looking at ways to store it as well, on regular Filecoin deals. So this is the demo right now.
All right, thank you so much, Thomas. Super cool. Again, everyone, please ask questions on the Slack channel. Let's go to the next one. This time from the Bedrock team, Peter Riba. Are you there? Yeah.
Yes, hello everybody. Cool. So what I'm going to show you today is a very rudimentary way of doing retrievals from Filecoin for just a part of the DAG that is stored in a deal. Now, this is all very, very early work. The upside is that it works with unmodified miners on Filecoin today. So all you need is basically just to apply a PR to your already existing PR to your client, and you will be able to do this yourself. The downside is that you kind of need to know what you put into the deal ahead of time and have some sort of structure and so on and so forth. So let's go to that real quick. So as you know, we run a little project called entity storage, where basically we take a bunch of really, really small content and aggregate it together into deals and then put this on Filecoin. This is one of the contents of such deals. What we actually do is we opted for very like basic old school Unix FS explicit sharding, where we literally take we normalize everything into CID version 1, and then we base that to CID version 1, and then we just take the last 2 characters, put it into a directory, then take the last 4 characters, put it into another directory, and then put the NFT or whatever the content is there itself. It can be a file, it can be like any other DAG. It doesn't mean that the gateway should be able to render it, but the actual directory structure is renderable. And the other important thing is that once we put all of this together, we have a so-called batch manifest, new line delimited JSON, where we put a full record of everything that we placed in this particular deal. So what I'm going to show you now is how this actually works from a retriever perspective, who only knows that there is a particular deal on the network with a particular PCID, and it has this particular manifest. It is prepared, you know, the way I just showed. So what you do is you one moment. So you know that you're looking for a particular PCID that is organized the right way. So what we do is we just go to a periodic dump of all the market deals currently available. This is something that you can do from your local Lotus node. You don't have to go to like to S3 or something like this, but just for the sake of the demo. And what we do, we basically do some, you know, JQ messaging, and we say like, we want everything where the proposal PCID is that, and then get me like the deal ID and which miners have it. So this particular deal has been stored with 5 miners, and as I showed you earlier, we have the very first file being a specific, well-known, defined thing. So let's go ahead and retrieve that. So what I'm doing here, I'm saying, you know, like usual, auto span retrieve a local for the sake of the demo, so that I actually pull it from my own node instead of going to the miner. And then this is the important part that the pull request in question allows. So basically what it says is that assume that the thing that I'm giving you is a Unix FS thing, go to its links, get the very first one, go to its hash, and then retrieve this stuff, and then put it in manifest JSON. So we're going to run that, and it's going to say success. And we're going to see what we have in manifest JSON. And what we have is this. So we basically have our preamble, which is basically a very, very short thing to let you kind of like figure out what you're looking at. Then a summary, like how many we aggregate in here, how are they sorted. So for example, we could do binary search on the rest of this file if you're looking for a particular piece of content. And then we have each individual, you know, thing listed, all whatever many, thousands of them. So then what we do, let's say we want, I don't know, let's take one of these larger ones. So for example, this one, let's say we want to pull out this CID. We know it is in this deal, but we don't really know where to look for it. But what we have here in this manifest, we also have it is in the 136th root directory, in the 248 subdirectory, and then the second entry. So we're just going to reuse that. And let's remember we have CJKY. So let's run that, but modify this to be, so then it links rep 136 hash links to 48 hash links to hash. Delete this part, and this should go into some NFT, whatever it was, I don't know if it's JPEG or whatever. And it's again going to run, and it's going to retrieve just the 13 kilobytes 530 of this particular file. And if I didn't do allow local, it would actually go ahead and do the deal with the miner. There are still some things that we're working on, specifically here. Like I already skipped my payment channel because I am expecting a max price of, I'm basically asking that I don't want to do a paid retrieval right now. But right now, basically what happens in the background is that the miner is unpacking this deal into a block store just to give me this little piece of data. In another, hopefully 2 to 3 weeks, we will land improvements where the miner will not have to do that. And this retrieval will actually be very possibly in the sub-second range. And yeah, that's pretty much my demo. And please ask questions for later.
All right, thank you so much, Riva. By the way, if, as folks present, if you have links to either the code that you use or the scripts that you used or the slides that you used, then if you want to share them on the Slack, that would be great as well. Cool. Let's go to the next one. This one is from the Pegasus team. So Peter and Zenya, are you around, ready to present?
Yeah, I'm here. So I'm just going to provide the very brief overview for people who haven't been following this. So we've got a single hop DHT that we've been working on for this current POC that we're almost ready to deliver. And so Zhenyang is going to show a quick video which will walk us through it. Anyway, over to you, Zhenyang.
Yeah, actually, Raphael, did you have a video to show first? Because
no. I only have the one of this morning, sorry.
Yeah, it's okay. I can.
So for those who don't know, we're a multi-time zone team. So syncing up exactly where we're up to at 6 a.m. in the mornings. Yeah, non-trivial.
Share my screen. Cool. Can you guys see my screen?
We can.
Yes.
Yeah, I haven't speed up the, hopefully it's the right video. So I haven't accelerated the video, which I will do it manually now. So basically what I did is I run a POC to integration test. So we haven't got unfortunately, we haven't got a user interface ready. So everything right now is through an integration test. So I just quickly, is there a way to like accelerate? Maybe not, yeah.
But yeah, so what Zhenyang's saying is though that we've got servers which are being run as Docker containers, and you've got libraries which offer programmatic APIs. And so at the moment, yeah, we don't have like command line tools to operate those programmatic APIs. The idea is to integrate those libraries into applications.
Yeah. Anyway, I just use this video as a way to show. Then I just go back to the slide. Maybe that's a better way. Cool. So can you see my slide?
We can.
Yes.
Yeah. Great. Okay. So yes, I probably just explain what happens in the video now. So I just briefly go through what happens in the POC2 test. So what happens first is that we first start a network of 32 gateways and 3 providers. Gateways are configured in a way so that their IDs are spanned over the entire DHT ring. In this case, that's from 0, 00 all the way to F8. Here is a screenshot of the network initialization taken from the previous video. We first tested the standard offer publish. So a provider can publish a group offer to some gateway nodes. And in this case, provider 0 publish an offer containing CID 0, CID 1, CID 2 to gateway 1, 10, 14, and 31. Here is just another screenshot of the standard offer publication. Then we use client to do a standard offer discovery. So client will pay and ask a gateway to discover offer containing given CID locally. And excuse me, in this case, client asks gateway 1 for offers containing CID 1. Here we just took another screenshot from the code of the POC2 integration test, which basically is how we use the client API to do standard offer discovery. Gateway 1 verifies the payment, looking through its local offer storage, finds the offer and responds the offer back to the client. So in order to minimize the offer size, instead of sending the original offer back, Gateway 1 will generate a sub-CID offer containing only the CID that the client is asking for, plus a Merkle proof showing that the CID requested is indeed part of the original CID array. So you could imagine that a provider can pack a few hundreds or maybe a few thousands of CIDs into the same CID offer. So in this way, we can minimize the bytes transferred between, between gateways and clients. So in this case, after client receives the offer, it will do 2 things. First, verifying the Merkle proof to make sure that CID1 is indeed part of the original group offer. And second, verifying the offer signature to show that this offer is indeed coming from a provider, so a provider 0. Here is just another screenshot of the process. And apparently it has only like 3 lines of logs, but you know the stories behind it. Up to this point, it is basically what we have done for POC1 integrated with the payment system. Next, we test the DHT network, starting from publishing offers. So provider can choose to publish offer to the DHT network. For example, in this case, we use provider 0 to publish a CID offer containing CID 4 to the DHT network. The provider identifies 16 gateways in the network whose IDs are closest to CID 4, in this case from gateway 6 to gateway 21. And here's another screenshot of testing publish DHT offer. So if a client couldn't find an offer, use standard offer discovery. For example, client does a standard offer discovery with gateway 27, but gateway 27 couldn't find any offer containing CID4 locally. So what the client can do is the client can choose to ask the gateway 27 to discover the offer using the DHT network. Client needs to pay for such request, and the price will depend on how many gateways client wish gateway 27 to contact. In this case, we use 7. In this case, we use 4. So client 27 will contact the closest 4 gateways whose ID is closest to the given CID. After gathering all the responses, gateway 27 will reply to the client all the responses it received. Then the client verify each response, decodes them to obtain the actual offer. And here's the logging when we do the DHT discovery, and it probably isn't very informative. Yeah. Finally, we add some new gateways to the system to test if gateways providers in the existing network can detect this new gateway and can update their DHT ring correctly. So yes, this is briefly what happened in the video we showed earlier, and it is actually a very simplified version of the actual testing. The actual testing scenario is way more complicated in order to test every functionality of this network. Probably in our next demo, we will have a user interface ready so we can do interacting demo. Yeah, that's all. Questions, comments. Don't hesitate to let us know. Yeah, that's it.
Thank you so much. Awesome. Yeah, I see that there are more questions appearing on Slack, and we have 2 more demos, and we have 17 minutes, 27 minutes left. So I think we'll still have some time for a live discussion. Next up, we have the W3DT team again. Hannah, are you on and ready?
Hey, yeah, I'm ready. Can I go ahead and share my screen? Hopefully this will work. I do this weird thing so that it doesn't. Oh no, I might need to.
Permissions. Yeah.
Yeah, I might need to do. Yeah, hold on one second. Which, if this doesn't work, like it might mean I need to leave Zoom, and like I maybe want to have. Maybe we should change the order. And
we can save you to last. Yeah, no problem.
Yeah, exactly. Yeah. Let me. What? Yeah, hold on one second.
Try that one quick magic trick, and then otherwise it's totally fine.
Yeah. Okay. Security and privacy. The Zoom.
I get beaten by that.
Yeah, I'm gonna have to leave to make this work. So okay. Go ahead and just whoever's next.
All right, Charles, you're next then. Are you ready?
Yes. It's my turn now, right?
Yeah, mic is on. Go for it.
Okay. Just me. Okay. I'm assuming. Yeah. So basically, like we're working on the proposal of S3 compatible storage gateway to Filecoin. So basically, like there was a couple of people was asking in the Slack about there was a project called Firebase, which is give you a bridge from S3 feels like SDK to the CR storage. So now people is asking that we have something similar in the Filecoin. So as a lot of people is using that, so we decided to make the Mineral IO, and we take it focus the Mineral IO repository and add some function with Filecoin. So basically, to easily understand is that we are export the key to wallet key, so we can copy the file locally, and from local we can upload to remote Mineral instance. Of the upload there, we will be able to generate a car file and start sending DLs to the Filecoin network. At the end, people will be able to retrieve the Filecoin storage DL from Filecoin network. There can be also retrieval of batch of files if the file was too large to are chunked to small files. Yeah. So I have a small video pre-recorded. We can just put it. So this is a tool of the MC. So it's command line tools. The first thing you can do is that you can make a repository using the common crawl data set from the screenshot. Yeah. So this part is for save the temporary generated car file. This is a tool actually created by a FileDrive team. They have created this IPability tool, so we just use that library. We chunk the data big files to small file and generate car file for uploading. Yeah, then we get the ID. Now I also generate a manifest CSV, which contains the different content and the CID, the piece ID of the car file, which can be used for sending DLs. It takes a little bit of time. Yeah, so it will split into 2 parts. All the information will be in the CSV. Maybe we can make it a JSON next time. We can those kind of information which will be needed for the media. Yeah, this is the Myel server. We start as a container locally, and then you will be able to synchronize it using the tool. You can export those security key and the server address, and using the wallet, which one you want to send the deals. But you need to run a node locally so you can send out the deal. Yeah, this is the command to copy the card to the Myel repository. Yeah, it's uploading to the Myel instance now. Yep, you can see the file was created. SID with the car file is synchronized. You can share with different places if you want. This is one miner we have for testing. Okay, so we have this command embedded in the CLI. Yeah. Okay, and upload to the network. This is the PR info. Now it's waiting for the miner input all the deals. They may take quite a bit time, usually 6 hours. At the miner side, you can check it to get the deal. Yeah, that's pretty much about the demo. So we still have work on finished yet. The remaining part is after it was stored, how can we retrieve those, put those CID on the GUI interface so user can directly copy the CID and start downloading and using the GUI to do the share. So this part is not done yet, but the first part of the command line almost done. Yeah, this is just a quick demo. How it works. Thank you.
Super, super cool, Charles. Thank you so much for sharing. All right, folks. So we initially booked, I believe, 50 minutes. So we would have like 6 minutes left. But also, like, if folks want to keep up to the hour, and if that works for everyone, of course. We got a bunch of questions to the demos. Some of them have already been answered. That said, well, I'll try to do my best here, moderate to pull the questions that haven't been answered. So Juan, is Alfonso still around? I think Alfonso had to leave.
I am here, yeah.
A question for me from Juan about the language for the smart records and its IPLD compatibility.
Okay, yeah, so actually we have a superset of, I mean, the language compiles to IPLD. So under the hood, we have IPLD, and it marshals to IPLD, and it could be stored, I mean, it's IPLD in the end, but it's a schema over IPLD, yeah.
Okay, yeah, that was the core of the question, like whether you have like some compiler tooling to transfer between, to convert between the two.
One thing we want to try is actually, because I know Danny is working on Reflect, and a Reflect tool for IPLD. So we want to try, because right now we use schemas, but we want to see how it works with Reflect and IPLD so that we can have code types the same way that we have code types right now. So this is something that we want to explore also.
There's some other questions in the chat on the Slack. I'm not sure if you're in that channel.
I think Alfonso is. So what about this? Because we have so many questions. Do folks have already written down? Do folks have new questions that you haven't asked so far? All right, and it seems Hannah is also ready to continue the demo, so maybe we'll just go with that.
Yeah, and I will also try to answer that question. I'm so sorry, y'all. Like, it's a long
problem.
story. I have like a dog who's like my beloved dog, and she's been very sick and just had to take that call from the vet. So we're trying to figure that out. All right, hold on one second. Let's try this one more time. Ooh, take my FaceTime off there. Cool. So yeah, Dealbots. The PL will eventually be publishing the results of the Dealbots we run so that they can be used by like reputation services. It will theoretically be maybe possible for multiple people to be running Dealbots and multiple reputation services to be consuming them. That's not yet happening. The code, however, is open source, and you can run your own Dealbot and use it to, maybe you even want to modify some of the tasks it runs to work with your software if you want to try some testing. That's kind of up to you. Let me just see that. Just so you all can see that it's already it's open source. Sorry, it's not like a giant announcement, but it's open source and it's available. You can just find it at Filecoin project/Dealbot. And there's a README that shows some of the commands that you run to get things started and how you can queue things. I am actually very briefly going to bring up my terminal, which is connected to a running Dealbot miner. You can see I've got this. Let's see if this works. Yeah, we have our controller running here. I'm going to actually stop it for 2 seconds so you can see here. This is the command. We're starting up a Dealbot. We're telling it where it's going to listen and serve its API, or starting up a Dealbot controller. We're telling it where to serve its API. It stores the tasks in a database. Here we're just using SQLite, but you can also use Postgres. And then over here is where we are actually running. Well, that might not have been the best plan to stop our controller for that Dealbot. In any case, and here's our command to start up our daemon. And you can see we're telling it to start, and we're telling it where Lotus is, and then we're also telling it how to connect to the controller. And so it's starting up, and if there are tasks available, then it will start pulling those tasks off. Here, I'm going to go ahead and actually start up a few tasks just so you all can see this. If you look at, so here's a list of 5 minor deals. These are all going to be retrieval deals. We're putting, so it's just a pair of miners and payload CIDs. This is just a JSON file. And so now I'm going to run our script, which will actually allow us to import those. So this is going to go ahead and queue those up into the controller. If we go back over to the controller, we'll see that they've been queued up. And then we are probably going to see that if we go back over to our Dealbot, that it is now starting to, whoa. Well, that's an error that we will need to check afterwards. You can see that it started to pull off tasks and execute them. We'll need to fix that in a moment. In any case, yeah, so that's what it is. It's mostly I don't know how much y'all were gonna want to like do it immediately. I mean, run Dealbots immediately for your own work, but it's nice to know it's out there, and it should, particularly those of you guys who are in the reputation world, this will be probably a useful tool for you. The relationship between Dealbot to the markets it finds and makes deals on. Yeah, I mean, so the Dealbot is intended to be a sort of like impartial deal maker that we're taking various steps to make it ideally actually not very gameable for miners. And the intent is for it to publish the results of its deals in a way that makes them, and those the deals will be, relatively impartially made so that you get some sense of how miners are doing in serving deals. That's kind of all I have. Thanks y'all for bearing with me and the multiple restarts of this presentation. And yeah.
All right, folks. Okay, thank you so much for the great demos and questions on Slack. Well, see you in 2 weeks. Keep up with the great progress. And I see that there's like a lot of people asking for links to try things out. So if you have time to share those, yeah. Well, I think there will be more questions after people get to try it out as well. All right. Thank you. Have a great week.